You're listening to DTFHN for May 15th, 2026. I'm your warranty-voiding host, Jack Hacksman. We are your daily tech feed for Hacker News, a website where people who could simply use the product instead choose to rebuild it from scratch. Today's a day for ripping things open and finding out what's actually load-bearing. Let's get into it. Let me make the case against this. You could argue this is pure nostalgia bait, a Windows XP skin over Wikipedia. It's a toy. It doesn't improve search, doesn't surface better information, doesn't make Wikipedia more accurate. It's a developer spending serious engineering time to make something that's functionally worse than just going to wikipedia.org. The file explorer metaphor is slower than hyperlinks. The desktop metaphor is a step backward from the web. Every serious UX person will tell you hierarchical folder structures are how computers organized information before we figured out better ways. Now let me tell you why that argument misses the point entirely. Some Smith built a full navigational interface over the entirety of Wikipedia's category structure. Every article opens as a document. Every category unfolds as a folder. Wikimedia Commons images are browsable, and you can right-click to set one as your desktop background. There's even an in-progress feature called GeoFile Explorer, where you navigate Earth as a folder tree, and can drop in images or text notes at locations. This is not a weekend CSS skin. This is someone building a genuine alternative interface to one of humanity's largest knowledge repositories. And here's the architectural fact that matters. They could build this because the data is open. Wikipedia's category taxonomy, its full article content, Wikimedia Commons, the geolocation metadata. All of it accessible, all of it remixable, all of it available for someone to walk up and reimagine without asking permission from a product manager or signing an API agreement. Smith's project sits alongside a whole lineage of Wikipedia reimaginings listed right in the readme.neil.funds wiki files, Wikiboard, multiple XP-style web recreations, an entire ecosystem of people taking the same open dataset and asking different questions about how humans might want to move through it. This is what open data infrastructure actually produces, not one canonical interface controlled by one organization, but a proliferation of experiments. Some will be toys, some will reveal something genuine about how people think about information. The folder metaphor might be a step backward for efficiency, but it maps to something deeply intuitive about how human minds categorize. The comments reflect this. People immediately start imagining variants, a book interface, a filing cabinet, a Unix desktop, each one a different spatial metaphor for the same underlying knowledge. The quiet detail worth noting, Smith's README ends by saying if you want to improve the folder structure, sign up for a Wikipedia account and start editing. The tool points back at the Commons. That's bootstrapism at its most precise. Build something with open materials. They invite others to improve the foundation you build on. Moving on. Buried in the README, there's a line most people scroll past. Every score is tagged direct, variant, base, interpolated, or self-reported, and discounted by competence. That word discounted is doing enormous work, because the dirty secret of the local LLM ecosystem is that half the leaderboard scores floating around Hugging Face are, to put it charitably, aspirational. Models inheriting benchmarks from their parent architecture. Quantized forks claiming the full precision number. Self-reported scores from uploaders who, and I'm being generous here, may have tested on a very favorable subset. Wisham is a command line tool by a developer named Andy that auto-detects your GPU, your RAM, your memory bandwidths, and then ranks which models from Hugging Face will actually run well on your specific hardware. One command. No interface to learn. Pipe it to JQ if you want it in a script. Now run this forward. The standard advice for running local models has been: check the parameter count, check your VRAM, pick the biggest one that fits. That's a size heuristic. It's like buying a car based on how much of your garage it fills. Which'll flips. This. It pulls from 6 real benchmark sources. Leave Bench, Chatbot Arena, Yelo, the OpenLLM Leaderboard, others, and cross-references them against what your hardware can physically serve at reasonable speed. The 27 billion parameter Qwen 3.6 outranks the 32 billion parameter Qwen 3 on a 4090. Not because it's smaller, because it's actually better, and it fits at a higher quantization. A size-only tool hands you the bigger model. That gap is the whole point. The VRAM estimation is genuinely architecture-aware. GQA, KV cache, activation overhead, OE, active versus total parameter splits, unified memory versus discrete PCIe, partial offload. One commenter pointed out that accurate memory estimation is the hard problem. Every runtime handles context differently. Sliding window attention changes the math. Fair critique. But the alternative is what we have now, which is people on Reddit asking strangers whether their 4060 can run Mixtral. The answer is always, it depends, and nobody specifies on what. The comments also surface a competitor called LMFit doing similar work. Good. This is how open source wins. Not one canonical tool, but a competitive ecosystem where the best implementation surfaces. The benchmarks themselves are open. The model weights are open. The hardware specs are public. The only thing that was missing was the glue logic connecting all three. And now a university student in Japan wrote it in a weekend. The 2 points you had open models running on hardware you own. No API key. No usage cap. No terms of service that change on a Tuesday. That's the quiet architecture of liberation. Not a manifesto, just a command that prints the answer. Hardware you own, software you control. Pause, that thread runs everywhere, even into my garage, where I just ripped the modem and GPS out of a 2024 RAV4. When did we agree that buying a car meant subscribing to a surveillance platform? I'm genuinely asking. There was no vote. No terms of service screen popped up at the dealership. You handed someone $40,000, and in return, they handed you a vehicle that phones home with your location, your speed, your braking patterns, footage from cameras pointed at your face, and hundreds of other data points. All monetized through brokers like LexisNexis before you made your first oil change. A security researcher named Arkadai just published a full teardown of removing the cellular modem and GPS from his 2024 Purvey 4 hybrid. And the procedure itself is fascinating. But what's more fascinating is the first principles analysis of what a car actually needs to drive. Strip away the marketing. A car needs an engine, a transmission, brakes, steering, and some way to tell you if something's wrong. Everything else is optional. The modem. Toyota calls it the data communication module. Is not load-bearing. Rip it out and the car drives identically. The GPS unit, also not load-bearing. Remove it and the wheels still turn. The cloud services you lose are services Toyota wanted, not services you asked for. But here's where the comedy kicks in. After removing the modem, CarPlay started teleporting him to the middle of Nevada. He lives in San Francisco. The car's GPS unit, now disconnected from the network, was feeding garbage coordinates to his phone, which his phone was dutifully accepting alongside its own perfectly good satellite fix. The solution was to remove the GPS entirely so the car would stop offering bad directions to a phone that already knew where it was. He had to make the car dumber so his phone could be smart again. And then the real punchline. Even after you physically extract the modem from the dashboard, if you connect your phone via Bluetooth, the car hijacks your phone's data connection and sends telemetry through that instead. The car tries to snitch on you using your own phone. You have to use a wired USB connection to avoid it. There is no setting to disable this behavior. It is architectural. This is what closed systems look like at the hardware level. The telemetry isn't a feature. It's the business model baked into the wiring harness. The fact that a security professional with a trim removal kit and a weekend can undo it tells you everything. The surveillance was never a technical requirement. It was a revenue decision that someone soldered onto your dashboard. The comments surface that Ford owners can pull a single fuse. Volkswagen owners are digging through companion apps. Everyone's independently arriving at the same conclusion. The only opt-out that works is the one you enforce with your hands. The off-switch Toyota wouldn't give you, "This guy built himself." That's the builder instinct working exactly as intended. So what happens when that same builder instinct turns toward something even more personal? Fuse your own health data. There's a question the diabetes tech industry has managed to dodge for over a decade. If continuous glucose monitors produce clean, structured, numerical data, the kind of signal that's trivially parsable, why does every major platform still lock that data behind proprietary clouds and companion apps you didn't choose? GlycemicGPT is a GPL-licensed diabetes platform, and the architecture tells you everything about the developer's intent. It connects directly to Dexcom G7 sensors and tandem insulin pumps over Bluetooth Low Energy. Direct BLE, bypassing the vendor cloud entirely for pump data. That's not a convenience feature. That's a philosophical commitment. Your glucose readings hit your own Docker stack, sit in your own database, get analyzed by an AI provider you selected and authenticated with your own API key. They call it BYOAI. Bring your own AI, Claude, OpenAI, a llama running locally, any OpenAI compatible endpoint. The platform doesn't care. It's a suggestions layer, not a control system. It will never actuate your insulin pump. That boundary is load-bearing, and they're explicit about it. The engineering that caught my attention is the plug-in architecture for device drivers. Community-contributed data readers, capability-based, designed so that if you own hardware nobody on the team has touched, you can write the integration yourself and submit it. The tandem Mobi support exists purely because someone mapped the BLE protocol and found it matched the Tannoy Slim X2. Protocol compatible, unverified on hardware, documented honestly. That's how open medical tooling should work. Transparent about what's tested and what's inferred. One commenter who loops with Android APS and Night Scout asked the right question. What does this add? The answer is the AI analysis layer. Night Scout gives you the data. GlycemicGPT gives you pattern recognition, daily briefs, conversational queries against a clinical knowledge base. Whether a language model adds value on top of already clear CGM signals is genuinely debatable, and some commenters push back hard on that. Fair, but the platform doesn't force the AI. Strip that layer out and you still have a self-hosted monitoring stack with BLE device connectivity, caregiver alerts, Wear OS complications, and printable reports for your endocrinologist. The developer runs this daily on their own body. That's not a pitch deck. That's someone who needed a tool, built it, and put the blueprints where anyone with a soldering iron and a Dexcom can reach them. 10 years of personal data storage on infrastructure you control, analyzed by models you choose. In a space dominated by closed ecosystems that treat patient data as a moat, this is the builder ethos applied exactly where it matters most. Moving on. I've spent enough time wiring up inference endpoints to know that where your model runs is not a detail. It's an architectural decision with legal, latency, and sovereignty implications that compound over time, which is why Relax.ai, backed by UK cloud provider Civo, caught my attention. The pitch is straightforward: sovereign LLM inference. Hosted in the UK. Data stays in the UK. For any organization bound by UK or European data residency requirements. That's not marketing fluff. That's a compliance checkbox that currently requires real engineering effort to satisfy. Now let's do the due diligence. The Hacker News thread is revealing because the commenters immediately asked the questions the landing page should have answered. Who are Civo? Where exactly is the data center? What's the corporate structure? Are the founders UK resident? These aren't pedantic questions. If you're choosing an inference provider specifically for data sovereignty, the entire value proposition collapses if the corporate entity is ultimately controlled by a jurisdiction you were trying to avoid. Sovereignty is a chain, and every link matters. From the silicon to the corporate bylaws. The Five Eyes objection in the comments deserves a direct response. Yes, the UK has expansive surveillance law. Yes, the Online Safety Act exists, but sovereign infrastructure and government surveillance are different threat models. Running inference through a US hyperscaler means your data transit system's subject to FISA Section 702, Cloud Act compulsion, and corporate policies written in Redmond. Running it through a UK provider under UK law at least collapses your regulatory surface to one jurisdiction. It's not perfect, it's better. The pricing question is worth pulling apart too. Someone asked why smaller models aren't 80% cheaper. Good instinct. If you can run Mistral 7B on consumer hardware, the value of hosted inference has to come from somewhere else. Uptime guarantees, compliance documentation, API compatibility, burst capacity. The infrastructure layer is the product, not the model weights. What I want to see next from Relax is radical transparency about their stack. Open source the orchestration layer. Publish the data center certifications. Name the hardware. Sovereignty without transparency is just another vendor asking you to trust them. And trust is precisely what sovereign infrastructure is supposed to replace with RIF-I-able architecture. The geographic diversification of inference capacity is genuinely important work. More of it, please. But with receipts. Moving on. In 1997, the UK government launched a project called the National Programme for IT in the National Health Service. It was at the time the largest civilian IT project ever attempted anywhere in the world. The goal was to centralize patient records across England. They handed it to the usual suspect: Accenture, Fujitsu, BT. By 2011, the program was scrapped. £10 billion spent. Almost nothing delivered. The post-mortem was devastating. But the lesson was simple. When you outsource your core capability, you don't just lose money. You lose the ability to understand your own systems. Now follow that thread forward to today. The UK Home Office has replaced a Palantir-built system for managing refugee cases with software built internally by its own engineers. The old system cost millions. The new one, according to the department, does the same job for a fraction of the price. And here's the part worth sitting with. The Home Office didn't just save money. It regained the ability to change its own tools when policy changes. That sounds mundane until you realize what the alternative means. Under the Palantir contract, every modification to how the UK processes asylum cases required going back to a defense contractor and negotiating a change order. The government had outsourced not just software, but decision-making velocity. Run the Palantir model to its logical conclusion. A government that cannot modify its own case management systems is a government that cannot implement its own policy in real time. Every legislative change becomes a procurement cycle. Every emergency becomes a change request. You have formally separated the people who make laws from the people who can implement them, and you've put a profit-motivated intermediary in between. That's not a technology choice. That's a governance failure. The commenters who've worked with Palantir's stack raise a point that deserves attention. The company embeds engineers on site, which creates deep dependency by design. Your free forward-deployed engineers are the lock-in. The expertise leaves when the contract does. What the Home Office has done here is not glamorous. It's not an AI story. It's not a moonshot. It is a government quietly rebuilding the capacity to run its own infrastructure, which is exactly the kind of work that matters most and gets celebrated least. The tools to do this have never been more accessible. Open frameworks, commodity cloud, modern deployment practices. The barrier is not technical. It is institutional willingness to invest in public capability instead of private dependency. We talked earlier about building from first principles. Story 7 takes that idea and runs it somewhere beautiful. Two mathematicians in Paris decided that building a machine learning framework in Rust wasn't hard enough, so they added category theory. That sentence sounds like a joke. It is not. Hamza Ghaliabi, an AI architect at Remo Lab, and Farzad Jafaranmani, a researcher with a PhD in fixed points of types in linear logic from a Curry-Howard-Lumbach perspective. And yes, that is a real specialization. Have published a working draft that treats ML pipelines as compositional mathematics. Domain objects become Rust types. Morphisms become typed transformations. Training becomes repeated transformation of model state. The entire pipeline is not computed. It is composed. Think of it like musical counterpoint. In counterpoint, you don't just stack notes. You define rules for how independent voices relate to each other, how they move, what intervals are permitted. The result sounds like music, but underneath, it's a formal system where every relationship is constrained, and every composition is valid by construction. That's what category theory does for this ML framework. Each layer, each transformation, each data flow has a typed relationship to every other piece. You can't wire things together wrong, because the type system won't let you. The Rust implementation matters here. Rust type system is rigid enough to actually enforce categorical structure at compile time. In Python, you'd be writing runtime checks and hoping. In Rust, invalid compositions are caught before the code runs. The framework targets tiny ML. Small models, constrained environments, which makes the mathematical overhead practical rather than academic. You're not paying abstraction costs on a billion-parameter model. You're using formal structure to make small systems provably correct. One commenter noted, fairly, that this looks like regular typed programming. Functions transforming data, types constraining composition. And that observation is precisely the point. Category theory, done right, shouldn't feel exotic. It should feel like the programming you already do, except now you have a language for why it works. The vocabulary lets you see patterns across domains that were previously invisible. The whole thing is open. Public repo, working draft, open feedback, workshop through AI Reading Club. Two researchers putting tools where others can reach them, building in public before it's finished. That's how knowledge compounds. And since we're talking about tools that meet people where they are, Let's talk about one that just leveled up. The top comment in the Hacker News thread is someone explaining what Dwarf Star 4 actually is, because the blog post just assumes you know. That's a tell. When 90,000 people read your post and the most upvoted response is, for those lacking context, you've crossed over from niche project to phenomenon before you've written the README properly. Anti-Red. The person who built Redis, which probably handles some fraction of the infrastructure you touched today, spent a week building a local inference runtime for DeepSeek v4 Flash. 14-hour days. And the thing that makes this worth talking about is his admission buried midway through. This is the first time he's used a local model for work. He'd normally send a Claude or GPT. Coming from someone who's been tinkering with local inference since the beginning. That's not hype. That's a phase transition. Now let me play devil's advocate for a moment. One commenter raises the obvious question. Why is this a standalone project when it's built on llama.cpp and ggml? Why not contribute up some Polish? And honestly, that's a fair challenge. The open source ecosystem doesn't always benefit from fragmentation. But here's where that argument breaks down. Anti-Res isn't building a general-purpose inference engine. He's building an opinionated experience. Single model, single focus, asymmetric quantization tuned for the specific hardware that actually exists on people's desks right now. 96 gigs of unified memory on a Mac Studio. That's a design decision. And design decisions don't belong in a committee-driven upstream. The hardware thread is revealing too. Someone compares this moment to early home computers. Mere toys before they weren't. That analogy is almost too perfect. The gap between local and cloud inference has been closing for 2 years. And DeepSeek v4 Flash with 2 8-bit quants apparently just closed it for a meaningful class of work. And then there's the line that matters most. Anti-Res closes with it. AI is too critical to be just a provided service. Run that forward. Every serious task you send to a cloud, a PI, is a dependency on someone else's pricing, someone else's content policy, someone else's uptime. When the model runs on your hardware, those dependencies vanish. The architecture shifts from client-server to sovereign computing. This is what the local AI movement has been building toward. The models got good enough. The hardware got cheap enough. And someone who knows how to ship software sat down for a week and wired it together. The tools exist. The weights are open. The rest is execution. So what happens when you take that same spirit of radical self-sufficiency and drop it, on a literally pause, onto the most remote island on Earth? Let me make the strongest case against caring about this story. It's a medical evacuation on a remote island. Happens all the time. Helicopters reach offshore oil rigs, Coast Guards pluck sailors from storms. Militaries resupply bases in Antarctica. Logistics solved by logistics. Move along. Except Tristan da Cunha isn't an oil rig. It's 259 people living on a volcanic island with no airstrip, 1,500 miles from the nearest runway, in some of the most unpredictable wind conditions on Earth. And the solution wasn't a helicopter or a ship. It was paratroopers jumping from 7,000 feet, 3 miles out over open ocean, drifting backwards in the wind toward a landing zone wedged between cliffs and sea. The cargo drops came in at 175 feet. That's below the height of most church steeples. Pull up the historical parallel. In 1942, the British established a secret naval station on Tristan da Cunha called HMS Atlantic Isle. A weather and radio monitoring post watching for German U-boats. The island mattered then because of its position. It matters now because people live there, and when one of them got sick with hantavirus from a visiting cruise ship, the response wasn't a cost-benefit analysis about whether 259 people justify an A400M transport and a Voyager tanker. It was just gone. The comedy of the situation is quiet. A cruise ship brings a virus to the most remote inhabited island on Earth. The hospital runs low on oxygen, and the solution involves an in-flight refueling rendezvous over the mid-Atlantic, a Pathfinder platoon from the 16 Air Assault Brigade, and a landing zone that doubles as a 9-hole golf course. One commenter noted the whole island has Google Street View. Another pointed out that Tristan's website itself is a throwback to when the web was good. And maintained, informative, no trackers, no pop-ups. Just people sharing what matters about their place in the world. 3.3 tons of medical supplies delivered by parachute to a speck of volcanic rock in the South Atlantic. Sometimes the most sophisticated logistics in the world exist to serve the smallest communities. That ratio is worth protecting. We talked earlier about pushing hardware limits. Well, someone asked whether the new RTX 5090 and M4 MacBook Air can actually game. Buried in the middle of the blog post is a sentence most people will scroll past. There is no driver for NVIDIA cards on ARM64 Windows. One line, no editorializing, just the quiet admission that an entire trillion-dollar ecosystem simply doesn't support this configuration. And then the author does it anyway. The setup is beautifully absurd. An M4 MacBook Air. An RTX 5000 Samsung. A Thunderbolt dock. macOS doesn't ship NVIDIA drivers for Apple Silicon. So you spin up a Linux ARM 64 VM. Pass the GPU through via PCI pass-through. And suddenly, your Ultrabook is pushing frames through a desktop-class graphics card. The VM is the same architecture as the host, so the performance penalty is minimal. The real engineering is in the plumbing. Mapping PCI base address registers into the VM's memory space, handling DMA, convincing macOS to let go of a Thunderbolt device so Linux can claim it. Pull this thread and you find the whole stack is open. Linux runs on Apple Silicon thanks to Asahi. The NVIDIA drivers work on ARM64 Linux. Thunderbolt tunnels PCIe over USB-C, which is an open standard. Every layer of this improbable machine exists because someone published their work where others could build on it. Meanwhile, Apple's official position is still that eGPUs require an Intel Mac. The hardware is capable. The protocols are capable. The limitation is a policy choice. One commenter called it proper mad science. I'd call it something else. This is what happens when the documentation is public. The drivers are available, and a stubborn person has a free weekend. The tools exist. Someone used them. This has been your daily tech feed for Hacker News for May 15th, 2026. This podcast is entirely AI-generated, scripts by Claude Opus 4.6, voiced by Quen3TTS, not affiliated with Hacker News or Y Combinator. Now go make something that's yours from the ground up. We'll see you back here tomorrow.